Welcome back to Arxflix. Today, we're diving into a fascinating paper titled Coincidence, Categorization, and Consolidation: Learning to Recognize Sounds with Minimal Supervision. This paper presents a novel framework that mimics human learning processes to improve sound recognition with minimal human supervision. Humans don't learn like machines. While machine learning relies on large labeled datasets, humans use multimodal unsupervised learning and active learning. Inspired by this, the researchers propose a framework to recognize sounds combining three mechanisms: coincidence prediction, clustering, and cluster-based active learning. Here's a visual overview of the learning framework. Each color represents a different loss function processing path, essential for understanding how this model works. The first mechanism is coincidence prediction. Based on the assumption that semantic categories change more slowly than the raw sensory inputs, this method uses temporal and cross-modal similarity to train separate audio and image embeddings. Here's how it works. Two tasks are used: predicting if two audio clips are temporally proximate, and if an audio clip and an image are temporally proximate. Both tasks help in learning a semantically meaningful representation for audio. Each loss function captures the balanced cross-entropy for pairs that are temporally coincident or not. Once we have semantically meaningful embeddings, the next step is clustering. This approach encourages confident assignments of data points to clusters while using all the clusters effectively. The loss function balances individual data points' entropy and the overall dataset's entropy to achieve good clustering, avoiding trivial solutions. Finally, the discovered clusters are consolidated into meaningful classes through cluster-based active learning. Here, a small number of element examples in clusters are labeled, and these labels are propagated to other elements in the same cluster. Training such a complex model requires a staged learning curriculum. The model first minimizes the unsupervised AV coincidence loss, then jointly optimizes AV and A coincidence, and finally incorporates clustering. Once clusters are labeled, the model is fine-tuned with supervised classifier training. These equations represent the combined loss functions at each stage of the learning process. The model is evaluated using the audio set dataset. The experiments measure unsupervised audio representation and lightly supervised classification tasks. Here's a look at the performance. In table form, we see substantial gains in query by example retrieval and shallow classification tasks, especially when combining A and AV coincidence with clustering. This innovative framework, inspired by human learning, allows for state-of-the-art, unsupervised audio representation with minimal supervision. By leveraging coincidence, clustering, and active learning, the model drastically reduces the number of labels needed, making it efficient and powerful. That's it for today's breakdown. If you found this video helpful, don't forget to like, share, and subscribe for more insights into cutting-edge research. Thanks for watching Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.